Hey guys, welcome back to College Algebra, and today we're going to try it using a video, and bear with me, this is the first time I've ever done this, so there may be a few burbles along the way, but hopefully we can make it through. I hope this finds you doing okay, and I miss you guys, and hope to see your faces in a couple days, but let's kind of go ahead and see how this goes. I hope you enjoyed the couple of activities we had yesterday that had to do with the rational functions, and if you haven't had a chance to do that, go ahead and check it out. There are a couple of Desmos activities, with one being the marble maze, so which I found kind of fun to do. As we go through this, I would suggest that you take notes, but if you just want to pay attention, that's fine as well, because you can watch this over and over. And I do plan on screenshotting at least some of it and getting it to you. So probably not the Desmos part, but you can always go grab those yourself. Okay. So we are going to try to go ahead and use the Elmo again so that I can write hand notes, and let's see how that goes. So today we're going to look at rational functions, and as you saw yesterday, they tend to have what are called asymptotes, and asymptotes are those lines that are invisible. However, they do shape how a graph reacts. Okay, so on the Desmos activities yesterday, you looked at how changing a number would change what it looked like, and those are just basic transformations like we've done in the past, and so hopefully their behavior wasn't too surprising to you. Okay, but now today we want to look at the equations a little bit closer and even delve into some that look different than what you looked at yesterday. Okay, and more we're looking at what determines where the asymptote is. Okay, our goal today will be just to be able to find horizontal asymptotes, which are the ones that go across, okay, and then the vertical asymptotes, which are the ones that go up and down. Okay. And then tomorrow we are going to take this information and actually graph by hand. Okay, so let's go ahead and look at our parent function, which we said looked like y equals 1 over x. Okay, and from the Desmos activity, hopefully you remember it looks something like this. Okay, so we have two branches, and one's in that top right corner and one's in the bottom left corner. And what we noticed here is that we had a horizontal asymptote at the x-axis and a vertical asymptote at the y-axis. Okay, so any rational function that looked like this with maybe a number added to the bottom or off to the side will look the same, but it gets shifted up and down. Okay. Now, for any other kind, how are we going to find those asymptotes? Okay, and the first thing we're going to look at is the vertical asymptote. Okay. And there can actually be more than one. And so I mentioned yesterday incorrectly, I apologize, but most rational functions will have a vertical asymptote. Okay, we will see a couple today that do not, but most have a vertical asymptote. Okay. And not only do they usually have one, they can have more than one. Okay, so most rational functions have at least one vertical asymptote. We could have two, we could have three. Okay, we won't deal with usually anything else more than two, but they could have more. Okay. Now, how do we find this vertical asymptote or asymptotes? Okay, and what you do is you set the denominator, okay, which is the bottom, equal to 0, and you solve. Now, when we do that, we're actually solving for what makes the bottom 0. And one of the basic rules in math is that you can never divide by 0. And so we're finding what does make the bottom 0, and that causes that jump in your graph because x is not defined at that place. Okay, so we're finding where does our graph have to stop, jump, and then start again. Okay, so we just set our bottom equal to 0. Now, if you look up here on our parent graph, if we set the bottom equal to 0, our answer is 0. Okay, so that's why we have a vertical asymptote at the y-axis. Okay, now we will write it as x equals a number. Okay, we don't just say the number, we have to put x equals because it is a vertical line. Okay, so when you are asked what's the vertical asymptote, you'll say x equals 2 or x equals 0. You want to write it as an equation, okay, since it is a line. Now this is where we'll start tomorrow when we want to graph. We'll actually graph our vertical asymptotes first, and we'll graph them as a dashed line because they are actually not part of the graph, they just form the graph. Okay, so that's how we find the vertical asymptotes. We set the bottom equal to 0. Okay. Then we can also find horizontal asymptotes. And the way we find a horizontal asymptote is a little bit different. Okay? And the first thing to note is not all functions or not all rational functions have one. So again, the majority of rational functions have a vertical asymptote, but not necessarily a horizontal asymptote. Okay. The second thing is if it has one, it can only have one. So at most it has one, but it doesn't have to have one. Okay. And it actually, when we graph it, it can be crossed. Okay. It may cross it or it may not. Okay. If you note up above in our parent function, okay, we have a horizontal asymptote here and it does not get crossed. So that's a scenario. Okay. But we do have one that it makes like a hill, and so it might come right across it and then go around it or come back down to it. Okay, so it can be crossed. That does remind me, I forgot something here on the vertical asymptote. Okay. This cannot be crossed. We did talk about it had to jump, but okay, vertical asymptotes cannot be crossed, but horizontal ones can. Okay. So horizontal asymptotes, to find them, we have to compare the degrees, okay, of the top and the bottom. So we're going to be looking at what is our highest power on the top and the highest power on the bottom. And this has to do with, especially if you get into calculus, you'll talk about it later, but it has to do how the polynomials behave as you get larger and larger and larger. It has to do all with limits. Okay, so for right now, you just memorize the rules in calculus. If you go that far, you can learn about it a little bit more. Okay, now there's 3 scenarios if you think about comparing numbers. They can be equal. The top can be bigger than the bottom, or the bottom can be bigger than the top. Okay, so let's look at scenario 1. Okay, and let's look at where the top degree is equal to the bottom degree. Okay, so when we have the top degree and it's equal to the bottom. So what happens here is you will have one, okay, but it's going to be y equals, and it's a ratio, okay? So it's going to be the lead coefficient of the top over the lead coefficient of the bottom. So it is going to be in the form of y equals the number. Okay. You're going to have a number on top and a number on bottom and reduce as needed. Okay. So that's scenario 1 when the degrees are equal. Okay. Scenario 2 is when the top is smaller than the bottom. Okay, so your top degree is smaller than the bottom. Your bottom is getting bigger faster than your top. And so when we divide by a larger number on the bottom, it gets closer and closer to 0. And so we do get y equals 0, okay, which another name for that is the y-axis, okay, or sorry, the x-axis. So if the top is smaller than the bottom, we get y equals 0 or the x-axis. And if you look up at the top in our parent function, okay, we have a degree of 0 on the top because we don't have an x, and then we have a degree of 1 on the bottom. And so the degree of the top is smaller than the bottom, and that says that our x-axis is a horizontal asymptote, and there it is. Okay, so there's our first basic example for that. Okay. So if you're keeping track, our third possibility is when the top is greater than the bottom. Okay. Now we said a rational function does not have to have a horizontal asymptote, and this is when this occurs because our top is getting so much bigger than our bottom when we plug in big numbers, since it has a higher power. So it's going up to infinity somewhere. And so we don't have a bound on it. Okay, so this is when there's not one. Okay. Now, in this course, according to Barton at least, this is as far as you have to go. Okay, and in the amount of time we have, this is as far as we have to go. But I will let you know there are other types of asymptotes, and that would be a oblique or a slant asymptote. Okay. And this would be a diagonal asymptote. Okay, so that can happen if we don't have a horizontal asymptote. Okay, so there are some scenarios where you don't have a horizontal asymptote, but you would have a slant asymptote. Okay, and again, for this course, we don't have to worry about it, but know that can happen. Okay, there's also what's called a hole or holes. Okay, and that would be when instead of having an asymptote, you just have a hole. So instead of a whole line, you have a one little spot where it's not defined. Okay, so this happens when you have repeated factors, something that can be canceled out of the top and the bottom. So it can't go away overall, but it does get rid of most of it. Okay, so these are others that we won't discuss past what I just said. Okay, if you're interested in them, I will just let me know and I can get you some information about that. Okay, but others that we will not discuss. So these are the ones that are the most important to us today. Okay. So let's go ahead and practice. You don't have any homework today except just getting ready for tomorrow. I'll give you 4 problems, I think, at the end that I want you to try to have ready so that we could look at tomorrow. But so as we go through this, let's just try to see if we can find out what the vertical asymptote or asymptotes are and what the horizontal asymptote is if it has one. Okay, we will use Desmos to just verify that we are on the right track. Okay, Desmos is an awesome tool. However, you are going to have to be able to graph by hand, so we are just going to use it as kind of a check. Okay, So let's go ahead and try our first example. Okay. See if I can get this where it needs to be. Okay. There we go. So example 1. Let's say that we have y equals 1 over x plus 4. So this one we actually probably could answer from yesterday's exploration, because if we cover this up, it is our parent function. Okay. All we've done is added 4 to it, which is x minus a negative 4. So this is moving it left 4. So that would affect our parent function's vertical asymptote. We should see it shift left 4. Okay. But our horizontal asymptote would have stayed the same because we don't have anything moving it up or down. But let's go ahead and look at it from an algebraic perspective. Okay, so to find the vertical asymptote, and my abbreviation is just VA. Okay, do you remember what we need to do? Okay. I know it was a few minutes ago. We need to set the bottom equal to 0. Okay, so we just take x plus 4 equals 0. And we solve for that, and we get x equals negative 4. Okay, so what we should see in a minute when we go look at Desmos is a vertical line at negative 4. Okay, and we won't actually see the line, but we should see our graph behaving differently at negative 4. Okay, so then we now look at our horizontal asymptote. Okay, and to look at our horizontal asymptotes, asymptote at most, is we need to look at the degrees. Okay, so vertical we set the bottom equal to 0. Okay, so here we have to look at our degrees, and the degree of the top is 0, and the degree of the bottom is 1. Okay, so how does 0 compare to 1? Well, 0 is less than 1. And if we go look at our notes that we had, that's scenario B, okay, or the top is smaller than the bottom, and so that is our x-axis, or y equals 0. Okay, and so we've found our two asymptotes in this case, x equals negative 4 and y equals 0. So let's go look at Desmos and see if Desmos agrees with us. And so we're going to do y equals 1 over x plus 4. Okay. And if we look here, we do have at negative 4 a vertical line. Our graph did change from going down to now being up here at positive infinity, so we definitely had a break and a change. Okay. And then if you look here at the x-axis, down here it approaches it but never touches it, and over here it's the same thing. So it looks like we are probably good on that. Okay, okay, so let's go and try another one. Okay, so let's try about y equals negative 4 over x minus 3. So again, using yesterday's, we could do some reasoning. This negative up here is going to cause a reflection. So instead of having it look like our parent function, it will be flipped. Okay, and then we do have something messing with the x on the bottom. So it should move it right 3. But let's just check. Okay, so vertical asymptote, all you have to do is set the bottom equal to 0. And so x minus 3 equals 0. So x is equal to 3. And remember, you do have to put the equal to 3. Okay. Or the x part, that is. Okay. And now let's look at our horizontal asymptote. And remember, with horizontal asymptotes, we check the degree. The degree of the top here is 0. because we don't have an x, and the degree of the bottom is 1. So just like our previous problem, top is less than the bottom. So our x-axis is again a horizontal asymptote. And you can either put the x-axis or y equals 0. Does not matter to me. So let's go again to Desmos and check it out. So we had a -4 over x minus 3. You would not have to have those parentheses, but so notice we do have over here, we would have had in the top left quadrant and the bottom right quadrant instead of what we usually have, and that is because of the negative. And then we do have everything that's shifted over right. Okay. Notice at +3, you do have a line that seems to cause this graph to change shape, and then at 0, the x-axis. Okay. So it looks like our work is okay. So let's try another one. Example number 3. Okay. So what about 3x squared plus 5 over x squared minus 4? Okay. Now this one's quite a bit different than our parent function. Okay, we have x squareds going on. Okay, and I really don't expect you to know what the graph would look like from this. Okay, it just would come from playing with it a little bit. Okay, but we would know that it does have some asymptotes. Okay, so to find the vertical asymptote, we set the bottom equal to 0 and solve. And again, remember we are looking for what makes the bottom undefined or what causes a jump. So that's, we can't divide by 0, so we're looking at what makes it 0. Okay, so x squared equals 4, and so then we have to take the square root. So we do get plus or minus 2. Okay, so here, not only do we have one asymptote, we have two asymptotes, okay, for the vertical part. Okay, so, and again, remember you can have multiple vertical asymptotes, but only one horizontal asymptote. Okay. So then let's look at the horizontal asymptote and see if it has one. And remember to do that, we look at the degree of the top and the degree of the bottom. Okay. So the top versus the bottom. And getting behind on my coloring. Okay, so the degree of the top, we're looking for the lead coefficient, and it is a 2. And you look at the degree on the bottom, and it's a 2. I apologize, I think I said lead coefficient, and I meant the degree. So the degree of the top is 2, and the bottom is 2. So that is scenario A in our earlier notes. And so these are equal. And what happens when we have equal degrees? That's when we have to go and compare our leading coefficients, or we take the ratio of their lead coefficients. Okay, so the lead coefficient of the top is 3, and the lead coefficient of the bottom is 1. And so then we reduce it if possible, and we get y equals 3. So here we have two vertical lines that are asymptotes and one horizontal line that's an asymptote. And before we go to Desmos, think a minute. Okay, how many pieces is your graph chopped into? Okay, if you have two vertical lines and one horizontal line. Okay, so think about it and let's go check. Okay, so here we have 3x squared plus 5. Now Desmos is really nice and it's easy to type into. If you're using your graphing calculator, make sure that when you graph this type that you put a parenthesis around the top and a parenthesis around the bottom. Otherwise it will graph or it won't graph what you're expecting. Okay, so be careful about that. So here we definitely have a different graph. You can tell we do kind of have a hyperbola shape up here, but we do have two vertical asymptotes, and we do have a horizontal asymptote, which we said was up here at 3. Okay. The number of pieces that this got split into is 6. if you think about it, because you have your vertical lines here, which split it into 3 pieces, and then you have this horizontal line that comes through and splits it into 6. And so just a little thing to think about. You can zoom out if you want to see what it looks like, the bigger picture. Okay, so let's go try another one. Don't forget that you may need to get up and take a break from time to time, and that's definitely fine, of course. I know it's hard enough to sit in class, but it does make it even harder when you're having to watch something like that. So pause, walk around, and get going. I've managed to misplace my pen. Okay, so let's try another one. So here we go. So we have 2x minus 1 over x squared plus 3x. Okay. So y is equal to 2x minus 1 over x squared plus 3x. Y'all are going to have to let me know if this writing is big enough, if I need to zoom in more, or what. We'll try to get the kinks worked out as we go. Okay, so vertical asymptotes, remember, we're just setting the bottom equal to 0 and solving. Okay, so x squared plus 3x equals 0. And we do have a quadratic here, so you need to factor or use a quadratic formula, something like that. This is the easy one to forget. Just take out a greatest common factor. So we have x times x plus 3. And using the zero product property, we have x is 0 as well as x is equal to negative 3. So here again, we do have 2 vertical asymptotes. And 1 this time is actually the y-axis, since x equals 0. And then to find the horizontal asymptote, do you remember what to do? Okay, we compare our degrees. Okay, so the degree of the top is 1, and the degree of the bottom is 2. And so again, the top is less than the bottom. And when that happens, we do get the x-axis, or y equals 0. Okay, so again, in this picture, we have 3 asymptotes, 2 that are vertical and 1 that is horizontal. Okay. And let's go check it in Desmos. So we have 2x minus 1 on top. And we have x squared plus 3x on the bottom. No, that's not right, is it? Okay. You can put x times x plus 3 on the bottom as well. That will work. Notice this one has still 6 parts. Your graph would have been, or the plane would have been cut into. And we do have 3 different pieces. So you do start to see some patterns. This one you can tell the shapes got kind of stretched and smushed together and things, but this is another rational function graph that we have. Okay, so let's go ahead and look at another one. Okay, so how about 10 over x squared plus 2? Okay, so if we go find our vertical asymptotes, again, we set our bottom equal to 0. And we would have x squared equals negative 2. And remember, when we take square root of a negative, we get i's. Okay, but we are graphing on a real plane. And will imaginary answers show up on a real plane? The answer is no. And so we have no vertical asymptotes. And so this is one of those occasions where I was wrong. I apologize about that, but you don't have a vertical asymptote. Okay. So let's see if we have a horizontal asymptote. So we compare our degrees. top versus bottom, we have 0 on top and 2 on the bottom. Remember, we just look at the powers of the highest x. And this is less than, the top is less than the bottom, so we do get the x-axis for y equals 0. Okay, so we should see a graph that has just one asymptote. And I was going to say something about the x squared from yesterday, but let's not worry about that. So if we go over here and graph 10 over x squared plus 2, you'll get like a whole hill that it goes up and goes back down. It does have the x-axis as a horizontal asymptote that's kind of shaping it. So far, so good. I have one more that I'd like us to try, and then we will, actually 2 more. No, just 1. Let's do 1 more. And then I will give you 4 that I would like you to try by tomorrow. And then we can start with those when we meet again or talk again. Okay, so we have 3x squared plus 5x minus 1 over x plus 4. Okay, so vertical asymptote is x plus 4 equals 0. So x is equal to a negative 4. Okay. So we do have one vertical asymptote. Okay. And then we need to look at the horizontal asymptote. And that's where we can compare the tops and the bottom degrees. Here we have a top is 2 and the bottom is 1. So the top is bigger than the bottom. And if the top is bigger than the bottom, that's our third scenario. And that's where we do not have a horizontal asymptote. Okay. So in this case, we only have a vertical asymptote. Okay. So let's go look at Desmos and see what it has to say. And we have, oops, it doesn't like me. So 3x squared plus 5x minus 1 all over x plus 4. Whoops. X plus 4. Okay. So you can see right now we don't have a horizontal asymptote. Okay. There's nothing that it's flattening out to. Okay. Looking at this graph, it brings up a pretty good example of if we were graphing this in our calculator, then we might miss out on what the actual graph looks like just because of our window. So our other graphs have been pretty much contained or given a pretty good picture in our basic window here, but I know that this should actually have 2 parts to it, and so it's missing a part. And so let's zoom out, and remember it's just a minus key up here. Okay, still nothing, but there we go. Okay, so it does have another piece that is down here. We do have that vertical asymptote that was at negative 4. Okay, right there. This one is one of those examples that has a slant asymptote. It has that diagonal line here that shapes this. Instead of being a parabola, it kind of shapes it. So, like I said, that's out of the scope of this class, but note there are other types of asymptotes. Okay, so hopefully that gives you an idea, and maybe you can go back and look at what we've discussed. But I would like you to try these 4 problems for tomorrow. And let's go ahead and look at those. So really what I want you to do is find the horizontal asymptote and the vertical asymptote, and if there are any, okay, and just have them ready to look at tomorrow. We will start with those 4, and We will go further and actually graph by hand, at least sketch, okay, by using not only our asymptotes, but our x-intercepts and y-intercept and other information that we should know from working on other things. Okay, so I need to modify that because I think that's like when we did. Okay, so let's do these 4, or at least attempt them, okay, for tomorrow. If nothing else, why don't you graph them and in Desmos, and you can see and maybe even work backwards. Okay, so it was great to kind of talk to you today. I hope this is going to be a fairly easy way for you to continue with the class. I know it's not what we all wanted, and you are going to be the class that has to do the most work, at least math-wise, just because those taking it for college, we've got to get through the material that's necessary. And as for details on your final and stuff, I don't know that yet. I do hope that you all picked up a packet that had a final review test in it and can at least start looking at that a little bit. And I'll have worked out answers for you eventually as well. Feel free to email me or email me specifically asking for a Zoom conference. We can do that too if you need help. But good luck, and we will talk to you tomorrow.